In this unit, we're going to be designing trebuchet arms, such as the one that is right here. So when we design these arms, what we need to do is make sure that we have a hole drilled for our pivot point, and then we also need to have a hole drilled for our counterweight. Notice there's a bunch of other ones in here. What those do is allow for some adjustability when we're tuning to find out what actually works better. And what you're going to be starting off with is just a 24-inch long piece of 3/4 inch thick by 2-inch wide pine, and that's what everyone will be working with. If you're not actually here, what you're going to be doing is submitting a scale drawing that shows us exactly where everything is, and we will actually construct it. And then when we're doing our tuning phase, we will be meeting live in class, and we will be asking you what you want us to do next, and we will be performing those things, and we will actually be testing the arm that you designed. We'll also be working on the slings, but we're not getting to that point just yet. So what we're looking at right now is the sketch of one of our trebuchet arms. So this section of it, from the end all the way to the pivot point, is considered the payload arm, and then the part of it that goes from the pivot point to where the counterweight attaches is considered the counterweight arm. So you can see what we have here in our drawing is we have it drawn out to scale. So this is on 11 by 17 inch graph paper. If you don't have that at home, as long as you have the scale written out so that we have all the measurements and we know exactly what size to make things, we can build those in here and then still be able to do our testing live via Teams. So this is just another example up on the board of, it shows an overall length of 24 inches. It doesn't necessarily have to be that. It can be shorter, but it can't be any longer than 24 inches. You can also use, for the end where the sling attaches to it, you can use either a finish nail, which works pretty good because it doesn't have a head on it that will catch the string, or you can also cut out a notch that works pretty well when releasing it. Sometimes that takes a little bit of tuning to get it to release at just the right time. This is one example of a student design. So this is actually drawn, like I said, to scale. So everything will have the measurements on it, and we will do our best to replicate it. So you need to be as clear in the measurement process as possible so we know exactly where to locate everything. Once our designs are transferred onto the piece of wood, then they'll be cut out using either the bandsaw or the scroll saw, or a combination of the two. And then we'll be going over to the drill press and we'll be drilling out the holes for the axles. So what we need to do right now is concentrate on getting the design ready. The students that are in class currently will be getting theirs done, and then once we receive your drawings, we can actually get those in the works and get those built. And then after that, we will be beginning our testing and tuning. When you're submitting your drawings, the easiest way to do that would be to just take a picture of it and then share that picture of it, which should be able to tell us anything we need to know. And then anything beyond that, be prepared to, during the times when your class normally meets, be prepared to be live with the class, and we will discuss anything that may need to be checked and just verify that that is exactly what you want to have done and that that does match your design. So over the next couple weeks, we will need to be working pretty much at the same time and be prepared to do live meetings. That's it for right now. Thank you.